So this is a case study, the Southern Flow Corridor Restoration Project. The full official name is the Southern Flow Corridor Landowners Preferred Alternative in Tillamook, Oregon. And all right, there we go. Just wanted to very first highlight the collaborators and researchers who have worked on this project. This is a restoration project that was completed in 2015, and I started working on it just about 3 or 4 years ago. So there's been a long list of folks who have been involved, including several who have already presented today. And sorry, one second. Apologies. Okay. So this is a project that I am now the current steward, but there's a lot that's gone on in the past. So a little background on Tillamook Bay and TEP. So I'm with the Tillamook Estuaries Partnership. And so our study area is the 5 estuaries in Tillamook County. Tillamook County, obviously more cows than people, so really quite rural estuary system. The Southern Flow Corridor project is in Tillamook Bay itself, or at the edge of Tillamook Bay. And on the left here is an aerial image of what the project looked like before restoration. So the project area was the kind of that area in the middle that you can see used for agriculture. And so these were areas that were, the kind of pretty wet pasture land that we've been talking about a little bit. And on the right, from the PMEP Estuary Explorer tool, the big green kind of in the middle, that's the tidal wetlands restored. That's the Southern Flow Corridor project, about 450 acres. And 2 primary reasons why the project was done were habitat. So this is really prime fishing habitat. But then the other reason that the project was done was for flooding. So this is just a FEMA flood hazard layer. And Southern Flow Corridor project is on the left side there, right where the floodway would go. And initially, before the project was completed, it was diked off and essentially backing water up. So it's one of the reasons why in this heavily agricultural county, we were able to actually get some very beneficial fish and in blue carbon as well, restoration done. So this is what it looked like before from up on Cape Mears looking down. You can see, the kind of left half of the site was not managed as heavily for agriculture, but that right side of the site is about 150 to 200 acres of cropped and grazed lands, kind of going back halfway towards Highway 101. And after restoration, this is what the site looks like as of just last year, I think, is when I grabbed this image. So the dike surrounding has been taken out for the most part. Does quite a few tidal channels were dug, and this is what it looks like now. And during a flood, of course, since this was an important part of it, during flood events, which we get really often in Tillamook County, the whole site is able to kind of take floodwaters that are coming over from the Wilson River, the Trask as well, and kind of not back them up onto where some residential areas are. So in this, just for the case study, I wanted to talk a little bit about the blue carbon monitoring that we have done in the past and what we're continuing to do in the future, and then end with just a couple lessons learned on the structure of some of the successes that we've had and how we were able to keep those going. Sediment accretion, this has been talked about a couple times. Obviously, it's not, the perfect method, but as John was mentioning, it's very widespread because it's cheap, because it's easy to implement. So I think the first of these were put in before restoration, so around 2015. And they've been alternately extracted with cryocore extractions or knife extraction, just digging them out. Feldspar marker horizons, and we've uh, done some soil chemistry on a few of these sediment um, plugs that we got out, and we're actually doing some right now. We hope to get those results pretty soon. Um, Higher accretion rates after restoration compared to the reference sites. So this is in part because a lot of southern flow corridor ends up being low marsh after restoration. And accretion rates are higher than local sea level rise. Obviously, this is before intensive remineralization, or the accretion rates that you get here may not be the long-term accretion rates, but because it's a disturbed site, we don't have those numbers yet for long-term post-restoration accretion rates. Deep carbon cores, so these were done in 2015, 1.5 to 3 meter cores, lead 210, as John was talking about as well. Density derived from CT scans and a subset using the drying method. Carbon content by loss on ignition. Pretty typical methods here. Restoration site has the potential to store over 27,000 tons of carbon, was one of the take homes from there, and long-term sediment accretion rate kept pace with past sea level rise. But this long-term includes, before human influence, but also while it was cropped and grazed pasture land. And we also did pretty extensive chamber measurements. So in 2017, and again, they're happening sort of this year. Portable FTIR gas analyzer, replicate chambers. So you can kind of see in the background, I've put some of the images for some context. Boardwalks to minimize ground disturbance between and the results, methane emission. I mean, this was known going in, pretty complex, non-linear with the environmental factors that we found, but and some relatively high methane emissions immediately post-restoration. So this is one of the things that we're really interested to see, does this continue? And one of the reasons why we're continuing to monitor the site almost a decade on and have plans to continue even further, because long-term behavior is really important for these blue carbon functions. And then a positive relationship between methane flux and groundwater levels, some indication that when doing these designs, it would be good to have designs that reduce ponding. And then finally, I just want to touch on some of the ongoing efforts that we have. So continued blue carbon and other monitoring. Blue carbon is a really important part of what we're doing, but we're doing a ton of habitat monitoring as well, fish use, vegetation, channel morphology. And we did, as Chris briefly mentioned, we set up, finally started getting some data in December, an eddy covariance tower. This is sort of during flood, but usually this area back behind the flux tower is low marsh wetland surface. And given the prevailing winds, we actually could set it up kind of on the shoulder of the dike and get still really good data from the wetland without needing to go and build a structure in the wetland. But that's really exciting. We're kind of awaiting results and what that's going to be like, but that's going to be a while before we really get that. And we're combining the eddy covariance, or the greenhouse gas flux, with chamber stations, accretion plots, and groundwater data as well, to sort of model drivers of CO2 and methane flux, and working pretty closely with Scott Brigham at U of O for that as well. And then just the one, I think, really important lesson learned from all of this for us that was really important is structure and continuity. So the monitoring plan that we had included blue carbon from the beginning and really laid out what kinds of things you would want to monitor and when. For this is only showing 6 years, but it actually went even further than this. And so if you're planning a restoration site and you want to do intensive monitoring and blue carbon monitoring, it really does pay to have that kind of structure for, not just 5 years, your before and immediate post restoration, but to have these plans really laid out for a long time, because then someone like me can come into the project know where things stand, and have a roadmap to move forward fairly seamlessly. And with that, I'll leave you with a nice picture from last winter, and take any questions.
Thank you, Colin. We've had 2 questions come in from the Q&A function. Question from Jacqueline. How did you determine the potential storage amount for the South Flood Area Restoration Site? Was it determined using the CAR and then calculated against the area for restoration?
Yeah, so this was using the kind of deeper soil cores. And I would have to go look at exactly what's in the papers that came out of that. But yeah, looking basically at the carbon content, and then looking at the area and what the potential was for accretion over time.
Thank you. And one more. One of your recommendations for managing methane emissions is that design should reduce ponding. How does this integrate with the occurrence of ponding associated with beaver activities?
Yeah, I think that's a really interesting question. And I think the ponding that we saw at Southern Flow Corridor was really, depressions where machinery or equipment was coming in. And so they're really shallow ponding is what we were seeing. And so these areas aren't necessarily providing the same kinds of habitat benefits that you would see in a beaver pond. And so beaver pond, I think that's an interesting area to look at for research. And I would actually be really interested in maybe poking around the site now and seeing if we find some beaver pond areas that we could look at methane emission adjacent to. But the kinds of ponding that I think we wanted to avoid in the future is really shallow areas that are just, in the summer, they're just going to be super hot because they're, again, really shallow, not providing any habitat benefit, and I think contributing to that methane.